So I hope your long break was enjoyable. I enjoyed and I rested a little bit before getting back on the grind. So that was good. So today we are going to uh, move to the next topic, which is descriptive statistics. Now, statistical analysis is based on probability, concepts of probability, which we talked about the last time that we met. So now we're going to talk about descriptive statistics. So now, statistical analysis, my definition of statistical analysis is the collection and analysis of unorganized mass data. Why do we say unorganized and then mass data? Now, everything that you do, everything that happens in nature provides data. When you wake up in the morning at 7 a.m. and somebody wakes up at 6 a.m. and somebody wakes up at 6:30 a.m., that is data. If you go to a poultry, all the eggs that are laid are not the same weight. That is data. The weights of the eggs, that is data. And why unorganized? Unorganized because events in nature are not like purposely set up so as to help your decision making. They just occur. Okay. What somebody eats at breakfast is their decision. They don't tell everybody, I am eating so much for breakfast. And they do not tell decision makers and statisticians they are eating so much breakfast or they spend so much money at the lunch table, what have you. So everything that occurs in nature provides data. And it is not organized. Now, in order for statisticians, for decision makers, whoever wants to use the data must, first of all, collect the data and then organize it in such a way that they can make sense, organize it so they can analyze it and provide information. So the job of statistical analysis is to not only collect and organize and analyze mass data, but to transform that data into information. Okay. For example, if you go to a poultry and you want to make so many bottles of, say, mayonnaise, you have to ask yourself, how many eggs do I need to make mayonnaise? This is number one. Number two, if the eggs are small, then you might need 1,000 eggs. If the eggs are big, then you might need 700 eggs, 600 instead of 1,000. And so, as a statistical analyst, you want to go to a poultry to buy eggs. You want to ask yourself, what is the average weight of the eggs? Okay, what is the average weight? So as to know whether you're going to buy 600 or 700 or 800 or 900. So there's some kind of distribution of the weights of the eggs. And so you collect the data on the eggs by whatever means, weigh them in order to know their average weight. And since they don't weigh the same thing, you can now categorize them according to their weights, those that weigh between 1 ounce and 2 ounces, those that weigh between 2 ounces and 3 ounces. And when you are done, that is how you come with the relative frequency distribution that we talked about earlier. Okay? With that kind of information, then with that kind of organizing and analyzing, then you get information. Information enables you to know whether you want to buy 1,000 or whether you need to buy 1,000 or whether you need to buy 600 or whether you need to buy 800. So this is what we mean by transforming data into information. Because then if you have information, you are able to make decisions. So today, we are going to begin with the basic concept that we use in statistics. Now, statistical analysis has two parts. There is the part that we call descriptive statistics. There is the part that we call inferential statistics. For the purposes of this class, we will just focus on the descriptive, which is to summarize data and obtain information about the basic characteristics, okay, of our data. Now, when we talk about basic characteristics, then it is at this point that we ask ourselves, you know, what are the characteristics that we're looking for, okay? What characteristics are we looking for? The most basic characteristic that we look for in any kind of data that we collect is the average, which we call the mean. And the last time we called it the expectation, the expected value. So that is what we're talking about. So in order to do statistical analysis, first of all, you must define a problem. You define a problem, and then you identify the variables that you are defining a problem about. Because in this case, the X, the variable that we're talking about here is the weight. You can look at the dimensions, okay? The area of the egg, okay? But here, the variable we're looking for is an average, and an average of the weight. So the weight is what is variable, and we want to get the average of that variable, okay? If you're looking at, say, kids in a class, the variable we're looking at would be their age, would be their height, okay? You are looking at working people. The variable we're looking for is their average wage, their average income, okay? And then so the variable is income. And then the characteristic of that variable is average that we're looking for, okay? So let's look at a simple example, and I'm going to take an example from your homework assignment. So when we are looking at average, we're going to look at a simple average, then we're going to look at a weighted average. Okay, they're two different things, but they give you exactly the same information, an average. Okay, I'm going to share I'm going to share a file. Okay? I know everybody here knows how to calculate an average. Okay. Here you see information, actually not information, you see data on the weight of a tea bag. Okay? You see tea here, and you see numbers here. These are the weights of a tea bag. Okay, tea weight. All right, tea weight. All right, so we calculate an average. An average is very simple. Okay, you take a set of numbers. Let's take a set of numbers and get an average. An average, how many do we see here? You see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So there are 17, and so the average here will be the sum of the values. So we can simply sum. Okay, so I am taking 19, and so the average here will be the sum of the 19 here divided by all the values divided by 19. Okay, so we get 5.5. Okay, or we can calculate an average to be and use we can use simply say sum equals average. We take the 19 that we had previously, and we get the same amount. So you can use your Excel facility to calculate the average by simply saying equals average bracket, and you paint down the line, and you get an average. This is what is called a simple average, okay? This is what is called a simple average. Now, the next thing that you can do is you can categorize, you can create a frequency distribution and use that frequency distribution to calculate an average. So I'm going to use your homework assignment to calculate an average. So give me a little time. Okay. Do you see the problem here on table 1? Hello?
Yes. Yep.
Okay, so now that is an example of a problem that you can use to calculate weighted average. So I'm going to let us describe the problem. Okay, let's describe the problem. So you have 3 neighborhoods: Crown Heights, Prospect, and Bed-Stuy. Okay. Now, what we have here is the percentage of the population in this neighborhood with a given kind of income, okay? The given kind of income. Now, what you see here is that the income is set up in such a way that it's in ranges, okay? But look at it. This is a frequency distribution, not a relative frequency distribution. For example, in this first neighborhood, 45 people have income of 19.7%. I'm sorry, 19.7% of the people have income less than 15,000. Okay, 19.7%. But that is 45 people have incomes of less than 15,000, which represents 19% of that population. So we're going to calculate weighted averages in two ways, using percentages and using frequencies. Okay, this is number one. Number two, we're going to also calculate weighted average that is not based on ranges. So there are two ways of doing weighted average. So I'm going to do the first one. So I'm going to stop share this, but I'll bring it up again. Okay. Okay, I'm going to use arbitrary examples. Let us say we have these T weights, okay? And so we have frequency. So let us say that 20 bags of tea have a weight of 5.32, 25 have a weight of 5.5, 30 have a weight of 25 have a weight of 5.77, and 30 have a weight of 5.5, and 25 have a weight. I'm going to make this very clear. Okay, this is the frequency. And 15 have a weight okay. So this is an example of a relative frequency distribution. So how do you calculate the average using this kind of information? What you do is you take X times F, where X is the value, 5.32, and the frequency of that value is 20. So you calculate 20 times 5.32, which is equal to D2 times C2. Okay, you do the same for the next 25 times 5.77. You do it for the next one. 30 times 5.5, and you go on to the end. Okay. All right. So now, how many observations did you make? The number of observations is equal to the total sum of the frequencies. And so that will be the total sum of the frequencies. So 115. So we observed 115. Okay. And so the average then will be the sum of the X times F, the XF here, sum of that will be okay. So the sum of the values X times F is 640. And so the average will be equal to the sum of the values XF divided by 115, which is equals E7 over D7, which is 5.56. This is a weighted average. But now the values are clear. The values are very clear. 5.32, 5.77, 5.5, 5.6, and 5.63. So these values are very clear. They are not in range of values. Okay? They are not a range. And so you calculate X times F, which is like 20 times 5.32, and 25 times 5.77, 30 times 5.5, 25 times 5.61. And then when you get all of that, you add them. And here we have 640.35. That is the sum divided by the number of observations, because we observed that the value 5.32 occurred 20 times. The value 5.77 occurred 25 times. The value 5.5 occurred 30 times. And so the total number of observations was 115. We multiply X times F for each of the observations, and we get to 640.35, and then divide by 115 to get 5.5. So this is a weighted average, okay? It's a weighted average. Okay, I'm gonna make it big so that I want to save it. So I will upload it so that you can see. All right. So now the next thing is to look at an example. I'm going to stop share this for a minute. So you can see, I'm going to copy this. I'm going to copy this and then I'll paste it here. Okay. All right, so this is the example from your homework assignment. So the question here is, which of these neighborhoods has the lowest average income? which of these neighborhoods has the lowest average income? So that is the question. But here you have the variable income. All right. So you have less than 15,000, 15 to 24,999, let's call it 25,000, 25,000 to 34,999, which is, let's call it 35,000. So how do you get a weighted average here? You can use the numbers as your weights. You can use these numbers as your weights. You can use the numbers as your weights, or you can use the percentages. Okay. But then how do you use these ranges of values? Okay. How do you use the ranges of values? How you use the ranges of values is that you calculate what's called a midpoint. Okay. What is the midpoint between 0 and 15,000? The midpoint between 0 and 15,000 is 0 plus 15,000 divided by 2. Okay. So the midpoint there is 7,500. What is the midpoint between 15,000 and 25,000? 15,000 plus 25,000 is 40,000. When you divide that by 2, you're going to get 15 plus 25 is 40, divided by 2 is 20,000. The midpoint between 25 and 35 is 25 plus 35, which is 60, divided by 2. And I'm going to make that big so you can see it. Okay. So the midpoint between 35 and 45, 35 plus 45, which is 80, and divide by 2. Well, what is the midpoint between 45 and more? Okay, you can choose an arbitrary amount. Okay, so let us choose 65. So 65 plus 45 is 110, divided by 2 is 55,000. And so to get a weighted average, you calculate M times midpoint times the frequency times C, and the C is the count. So we call that the frequency of 45, 69, 64, 24, and 27 and 24. Okay, so those are the frequencies, or you can call them count. And what is the sum of the frequencies? Equals sum. Okay, so there are 229 observations. So there are 229 observations altogether. So M times C, that is the midpoint times the count, will be equal to the sum of equals, equals D6, which is the frequency times J6, which is the midpoint. And then we'll do that for every observation. All right. So what is the sum here? We add the multiplications, and so the average will be equals A12 divided by D12, which is the sum of the multiplications divided by the sum of the frequencies. And so the average income for this first neighborhood will be 26,364. That is a weighted average. Okay. Now you do that same calculation for the other two neighborhoods and find out which neighborhood has the lowest income. That is a very simple process that you can implement. Now, if you want to use percentages, then you don't need any sums. You don't need the sum of the frequencies. The sum of the percentages is 1, or 100. So this is what you can do. You can then use the midpoint times the percentage, okay? This percentage here, okay? Which is the relative frequency. And so you can simply then say equals E6 times the midpoint, J6, and you do that for every observation. Okay, and this time the average will just be to this is sum here. Okay. This is weighted average. And you just have to add numbers. And what do you get? You get exactly the same value. Okay, 26,362 are slightly different here because of the approximation of the averages here, but you get the same solution. Okay, so don't worry about the minor difference there. Okay. All right, so we have illustrated the computation of averages from simple average. Then we computed a weighted average with absolute numbers, and then a weighted average with ranges of values. So this is essentially what we have covered this week, and you should apply these methods to your homework assignment. So I'm going to stop share this. All right. So does anybody have any questions?
Yes, Professor. This is pertaining to the homework, not like what you just did.
Yes.
Like, could you go over a question via Excel where you're doing a problem with sorting?
Okay, let me see if I get what you're talking about.
There was a question on the homework, I believe it was question 4, that's dealing with sorting.
Dealing with what?
Sorting, like sorting the data.
Oh, okay.
Yes.
I see what you mean.
Mm-hmm.
I'm facing some kind of tech challenge here. Okay, let's see. This is week 13.
Week 13, yes. Let me double check.
I don't see anything with sorting the data.
1 second, I'll tell you just now.
Oh, okay. All right.
That's the last question, number 4.
Let's see. Okay. All right. Okay. So I'm gonna pull it up, okay?
Okay.
Okay, I'm gonna share screen. Okay, is that what you're talking about?
Yes, Professor.
Okay. What did I ask you to do? That's about sorting data.
1 second. So this said the attachment Excel contains data that contain data, the bus feed of Burnell School District. So it's
Okay.
saying sort the data by type of bus manufacturer and calculate the average cost of maintenance of each manufacturer.
My. The data is already sorted anyway. You can see you have, you can see Bluebird comes first, then Kaiser comes next, and then Thompson comes next. So you don't need to sort the data anymore.
Okay.
Okay. Now, if you, since I downloaded this from your problem, so it's not gonna distort it, but if you want to learn how to sort data, this is what you need to do, okay? Let us say we want to sort the data by fuel type. Diesel, gasoline. Okay, so it's only diesel and gasoline, right?
Yes.
Okay, so let us say we want to sort the data by type of fuel. What you need to do, see, the the variable names are in X4. Okay, so we're going to use in row number 4. So we're going to paint the whole thing. You see it? After you paint it,
then press data.
Press data, so you know how to sort it. So
I did that, but for some reason it wasn't working for me.
No, because the data is already sorted. So you don't need to go through that. Okay. And so you go to data. Okay, you go to sort. All right. It's already, you see, it's already sorted by gasoline, what have you. I just sorted it. No, it's not sorted. Okay. This is, all right. Start by X5. It's going to close the program because I'm facing some technological issues here. Okay, the screen stopped sharing. I'm going to pull it up again.
Your Excel said it's done for the day.
Yeah,
No more calculations.
Sometimes you all face technological issues. Yeah, I'm having some problems, but as you can see, you click the sort and then you select the column you want to sort by, and that will be that. But I am facing some tech issues here.
This file was giving me a little bit of trouble too. I ended up making a pivot table to get the calculations.
Okay, so if you already have figured that out, so then we don't need to go through it. Okay, so any other question?
Oh, that was Jamila's question. Sorry, I didn't mean to hijack it.
Okay, no problem. No problem. My system is freezing. That's why I understand when students say the system froze, that's okay. I already opened the assignment for you. You just frozen. Okay. But besides that, any other questions?
Yeah, so regarding that one you were that just closed on you.
Mhm.
The homework says to present the information in a table,
Okay.
and I put it in two separate tables, and I just wanted to make sure that was an okay
Okay.
way to approach it.
Two separate tables for what?
So one of the questions was, you know, sorted by manufacturer and calculate the average
Okay.
cost of maintenance. So I put that in a separate table. From
Okay.
the next question, that was sorted by fuel type and then calculate the average cost of maintenance and the average of miles.
Oh, that's
Yeah.
fine. That's fine. That's fine. That's fine. Yeah, you know, you will make two separate tables.
Okay,
All right. Any other question?
that's it for me.
All right.
That's it. Thank you, Professor.
Okay. All right. Good night, everybody. Thanks for
Thank
coming.
you.
I'll post this. All right.
Good night.
All right.